Welcome to this special episode of Frequency Matters, the R for Microwave Update series. I'm Pat Hindle, and I'm talking today with Marcus Olbrich, Head of Program Management at Hella, and Nils Dagås, R&D Director at Gapwaves. Welcome, Marcus and Nils.
Thank you.
Hello, Pat. Thank you very much.
So automotive radar is kind of undergoing a big change in technology as semiconductors and antenna technologies are improving every day. So we're going to discuss today a unique antenna technology that Gapwave has developed. Nils, can you tell us about Gapwave's unique Waveguide technology that's used to make low-loss antennas? And can you tell us about that technology and how it works?
Yeah, sure. Gapwaves, they're created in a technique that they use a pin pattern that acts as a metamaterial that acts as an artificial magnetic conductor that is contained in the electromagnetic field. And the good thing about this pin structure is that it allows for that you can build up without having contact between different layers of the waveguide. So you can have a gap, hence the name gap waveguide. And this relaxes tolerances and takes away the need to solder the parts together. And at the same time, this also provides the same low loss and performance and the same transmissions modes as a traditional waveguide.
And automotive radar is a good fit for this technology. So, what advantages does Gapwaves bring to the automotive radar market?
Basically, Gapwaves brings together the best of both worlds. They enable the waveguide performance at patch antenna cost. So these relaxed tolerances really suits the environmental requirement for the automotive sector, where you need cost-effective antennas that still has high performance. And besides that, since they also become significantly thinner, that also helps with integrating the technology on the vehicles. And besides these lower losses, that of course can be used for getting longer range of the radar, the wide bandwidth of the antenna also enables precision range resolution down to just a few centimeters. So you can use them, for example, as an advanced parking sensor as well. The bandwidth also helps being able to choose a frequency which has less interference. So with the recent deployments of multiple radars in vehicles, the frequency spectrum is becoming quite crowded. And this is an increasing problem as I get more and more radars on the bands.
And Marcus, Hella's partnered with Gapwaves to bring this waveguide antenna technology to the radar sensor. Can you tell us about the collaboration you have and what kind of products are realized?
Yes, of course. So maybe let me start first with the fact that we are looking on a long history of radar development now. So we started already in 2002 with the first radar development. And throughout all the years, we have always partnered with strong players in the market to realize the best possible products for our customers. And we do have a lot of in-house know-how, but we think that if you want to design a leading product, then you also need outstanding partners for every technology. After recognizing that waveguide antennas offer a lot of technical advantages, as Nils just described, we directly started to assess different players on the market, and we came to the conclusion that Gapwaves offers the best technical solution for this kind of technology. And so we decided to partner, and we also invested into Gapwaves, so we have a strong basis now for this collaboration. Gapwaves technology offers especially a high robustness for mass production. So we produce up to 40 million sensors a year. And if you have such high volumes, you must be absolutely sure that the product is robust in every direction and that we can deliver a stable, high quality to our customers. And on sensor level, the Gapwaves technology also offers a very high performance in combination with leading radar SoCs. We can offer high ranges, good resolutions on a reasonable cost level. All these targets have been achieved now. Meanwhile, in two generations. We have developed our sixth generation, which will go into serious production by end of this year at a German premium OEM. And we have already started to also develop our seventh radar generation.
Wow, that's a really high volume. I didn't realize you were making that many of them. So what progress have you made in the last year for the deployment of your technology, Nils?
Yeah, the technology has now been around for many years and gradually matured. This is especially important for these high volume products such as automotive radars. So this year we have taken an important step by entering the start of production phase for automotive radar.
And Marcus, how about you?
Yeah, as I already mentioned, we started to the serious production of our sixth generation. So the SOP will be end of this year, which means that we already now have to start with our ramp up phase. So I would say this is the main achievement that we have brought jointly with Gapwave, this technology to a serious maturity. And we are now focusing on the development of our next generation, which comes with a higher channel count and with even further improved performance KPIs. Yeah, and we have a worldwide production footprint that will manufacture this new sixth generation. In total, we are talking about 20 production lines worldwide, and we have to ensure a very high quality. Our quality values are going in a direction of 2 ppm on our existing production lines. So that means only 2 out of 1 million parts are somehow showing topics that are to be claimed by our customers. But I think this is a very good reference for the market.
Yeah, it's a high level of quality there. So what future plans or developments do you have for this Waveguide technology, Nils?
Yeah, the demand for better resolution to enable higher levels of autonomy in driving, that will push for larger antenna apertures. So while there will be a continuous need of cost-effective small arrays, there will also be more complex multi-channel antennas required. And this large antenna also creates other challenges, such as they need to be integrated into the vehicles. So continued improved antenna integration into the sensors, as well as enabling that in the vehicle, is an important next step. Another area that is common is everything that is possible to do with Waveguide, such as Waveguide filters, which could also be made in the Gap Waveguide technology. And this also allows for very compact solutions with filters. And with the millimeter wave spectrum becoming more and more utilized, demand for filters will likely increase.
And Marcus, how about on your side?
Really prepare for the next performance level of radar sensors. So we see right now that first serious production vehicles with level 3 automated driving functionality are on the street. And we see this as a clear signal that this will be a growing market in the next years. And this functionality of level 3 automated driving clearly requires higher performing radar sensors with a much better resolution as we see today compared to today. And that especially means we need higher angular resolution. Higher angular resolution also means a much higher channel count. And therefore, we are preparing exactly for that step and designing. We are in the design phase of first high resolution radar device on Hella's side. Of course, as always, with the ambition to be on a very high performance level, but also on a very good cost level as well. And this will be also realized together with Gapwaves. We are already in production of the first A-sample antennas, and the very compact design of the Gapwaves antennas will definitely enable us to realize a very competitive product for that market as well.
And I'm wondering, this is a very interesting technology, Nils. What other types of applications or markets would it be good for?
Yeah, anything that is sufficiently high frequency that is suitable for waveguides, we can do that even better with gap waveguides. That could be other radar products, such as in traffic management, but also for communication. So both for telecom fronthaul or backhaul or satellite communication. It could even be used as low-loss distribution of really high-speed digital signals. And also an important issue to remember with these gap waveguides is the contactless signal transfer that you can make with the technology. So the relaxing of the mechanical tolerances, this can be used for interfacing. For example, today it's between PCBs and antennas without using gaskets and screws. But only the imagination sets the limit for what application you can do with this contactless transfer. So all the way from building completely novel structures to things like reducing wear in interfaces, or even allowing for moving or rotating signal transfers.
And how about filtering? Is it good with that area too?
Yeah, the filter, as I mentioned earlier, waveguide filters can be very compact in this technology, and that allows for more compact solutions. So getting into systems that are multi-channel, such as base station and so on, that could be a very good technology to have compact but effective filtering.
Well, excellent. Thank you, Marcus and Nils, for talking with me today about this unique antenna technology, how it's being applied to automotive radar. We look forward to continuing to watch how this develops and hope to have you back. And to our audience, you can find more videos at videos.mygravejournal.com. Thanks for watching.